Here in example 2, we're given the coordinates of the vertices of an ellipse and the coordinates of the foci of the ellipse. And we want to find the equation and graph it. So first notice that the vertices and foci are both on the x-axis. And remember, the foci and vertices are always on either the x-axis or the y-axis, but they will be together, both on the x-axis or both on the y-axis. Here, they're both on the x-axis. So this is what I call a wide ellipse. It's wider than it is tall. From the vertices, we can determine the value of A, and from the foci, we can always determine the value of C. So A must be 4 and C must be 2. Therefore, we know the relationship between A, B, and C is that C squared is always equal to A squared minus B squared. A is always bigger than B. So C is 2 and A is 4, so 2 squared is equal to 4 squared minus B squared. Well, that's 16 minus B squared equals 4. You must subtract 12 from 16 to get 4, so B squared must be 4. Or excuse me, must be 12. So now we have all of the necessary information to be able to write our equation. We know the equation is x squared over a squared, when it's a wide ellipse, plus y squared over b squared equals 1. And we know a squared is 16 and b squared is 12. So our equation would be x squared over 16 plus y squared over 12 is equal to 1. Now graphing this on paper is relatively easy because you know the vertices are at 4, 0 and negative 4, 0, and the foci at 2, 0 and negative 2, 0. To find the top and bottom points of our wide ellipse, we just have to take b squared and square root it to find b, because those coordinates will be at 0b and at 0, negative b. Well, square root of 12 is something between 3 and 4. So you notice in my graph here that I have plotted my ellipse with the top and bottom at a value between 0, 3 to 0, 4 and 0, negative 3 to 0, negative 4. Graphing it on our graphing calculator is also relatively simple. We just have to be careful about when we enter this into this equation editor. When I go to type x squared, I have to hit arrow out of the exponent before hitting divided by 16. And then I have to arrow outside of the fraction to go ahead and type the rest of the equation. So then it would be plus y squared, arrow outside of the exponent, then hit divided by 12, arrow outside of the fraction, equals 1. And we see it looks very much the same as the one we drew on paper.